students, today we are going to start a new topic. The name of our topic is Introduction to Three-Dimensional Geometry. See, three-dimensional geometry means we will have now three different perceptions, or you can say that three different axes. First of all, we shall see what we have learned so far. Means already we have learned about the Cartesian plane. In that we have learned about the two-dimensional geometry. As you can see in front of you right now, a Cartesian plane is there. In the Cartesian plane, you know that there are two types of axes are there. Means there are two types of dimensions are there. One is called as the x-axis and second one is called as the y-axis. So this is my x-axis and this will be the y-axis. Okay, and as you can see, these two axes divide the whole Cartesian plane into four parts. These four parts are called as the quadrant. This is first quadrant, second quadrant, third quadrant and the fourth quadrant. You also know that in the first quadrant, the x and y coordinate are both are positive. Similarly, in the second quadrant, the x coordinate is negative and y is positive. While in third quadrant, both are negative. Okay, that we have learned in the class 10th also, and in class 11th also. In the straight line you must have done this kind of things. Similarly, in the quadrant 4th, you know that the x coordinate is positive sorry, and y coordinate is negative. Okay, so this all concept we know. For example, if I talk about the lines x and y, where they are going to intersect, they are intersecting at the point O, that is origin. Okay, so here the concept about the two-dimensional geometry we all knows very well. Now what is the need of three-dimensional geometry? You must have seen some of the cartoon movies or some of the pictures where the three-dimensional figures are shown. When three-dimensional figures we see, on that time we can easily observe the figures are figures look more real. Okay, in comparison to the two-dimensional geometry. So first of all, let us see the basic need of three-dimensional geometry. Suppose if they say we wish to locate the position of the lowest tip of an electric bulb hanging from the ceiling of a room, or the position of central tip of the ceiling fan in a room. Suppose there is a bulb or a fan hanging onto the ceiling, so we want to locate its position. Normally we don't use the methods of coordinate geometry in our day-to-day life, but suppose if we apply, then if I want to find out the position of the bulb which is in the room, so that how we will find out. First of all, see what is written for them will not only require the perpendicular distance of the point to be located from two perpendicular walls of the room, but also the height of the point from the floor of the room. See, suppose this is a bulb we have. Okay, and if I talk about, if this is one of the wall, so this wall, if I say this is my y-axis. Okay, and the ceiling of the room, suppose if I say this is one of the perception or one of the dimension, this is x-axis. So these two things are only not sufficient. We need to find out how far it is from the floor. So in that case, we required one more dimension, that is called as the third dimension over here, or we can say that the z-axis. So that only thing they are talking about. Let us complete that one. So they are saying therefore we need not only but three numbers representing the perpendicular distance of the point from three mutually perpendicular planes. See, this walls, the two walls and the floor, we can say these are the our mutually perpendicular planes. Plane is nothing, it is a rectangular surface, we can say, and a very thin surface, we can suppose, which has no width. Okay, so these three perpendicular planes we are required. And what they are saying for them, namely the floor of the room and two adjacent wall of the room. The three numbers representing the three distances are called the coordinate of the point with reference to the three coordinate planes. So whichever the numbers we are taking, suppose if I am taking alphabets here x, y or z, so that they are talking about the names. So a point in a space has three coordinates. In this chapter, we shall study the basic concept of geometry in three-dimensional space. Okay. Suppose if I say numbers, if they talk, if they are saying about the numbers, means suppose if I say I have the coordinate 1 comma 2 normally. So here we can say x is represent sorry 1 is representing the x coordinate, okay, and we can say that the 2 is representing the y coordinate, okay. So here we can say similarly for the z axis also there is one more coordinate we required. So suppose if I say 1 comma 2 comma 3, so the third coordinate will be representing the z axis, okay. So here we can say this third axis will have their separate coordinates, and we shall write down always the coordinate in the form first of all the x coordinate, then y coordinate, and then z coordinate will come. Okay, now I will show you how we can take a look of the three-dimensional plane. Yes, now see, this is the one figure in front of you. You can see there are three different planes we have taken. See it carefully. Sorry, there is one plane, it is in the violet color, okay, which is in front of you. Then one plane is it in the blue color, light blue color, that is horizontal, and one is looking in the vertical, that is in the orange color. So orange color plane we can see that will be our z axis, then the violet one that will be the y axis, and the light blue or the sky blue color plane is the x axis. Now you observe the whole three-dimensional plane is divided into how many parts? If you see the Cartesian plane, that was divided into four quadrants, but here the situation is different. You can see if you are looking the view of your house, then it will look like a room. Suppose if we talk about this particular one, okay, I cannot point out properly, but I will try. See this one. If you talk about this particular box, okay, so this box you observe, it is one of the part. So this particular part if we talk about, then this is called as one octant. Why it is called as the octant over here? Because here it is divided into 8 equal parts, okay. See it properly. See in front we will be looking 4 equal parts, and at the back means at the back side of the z axis you can see again 4 parts will be there. So total 8 parts we can say the three-dimensional plane must have, okay. In the coordinate plane, Cartesian plane, we can say there are 4 quadrants, 4 equal parts are there, but here we can say they will have the 8 parts, and these 8 parts are called as the 8 octants. So now suppose if I want to find out, suppose if I have given the coordinate over here, suppose 1 comma 2 comma minus of 3, suppose it is given, and I wish I wish to find out it lies in which octant, then how we shall find out, that we shall study. Okay, so first of all let us see that things, and see if we wish to locate the third axis over here, normally we draw a line in the form of diagonal in this manner. See, I will show you. See, this is your y-axis, this is your x-axis, and from here, from the origin, you can draw one line like this. Okay, so you will say that this will be the z-axis over here. So this axis you can increase also if required. Otherwise, this will show one of the axis over there. Okay, so now suppose if I increase this one, and if I keep like this will be one of the axis. Okay, now suppose if I say this will be the x-axis, this will be the y-axis, and this will be the z-axis, suppose. Okay, so now the z-axis is coming, actually the z-axis will be coming in the form of one of the plane, that plane will be there. Okay, so you assume x-axis is horizontal, y-axis is vertical, and x-axis is coming, sorry, z-axis is coming in your front. Okay, so back side of the y-axis, the z-axis will be negative, and the front of the y-axis, it will be positive. For example, suppose if we change the name over here, now in this way you think, suppose if I say this is z-axis only, the orange one, and this is y-axis. Suppose if I say, if I take in the same way, actually they have taken the z-axis backside positive and in front it is negative. So we'll change the name. So here some this coordinates, it is coming the minus minus plus, that will look different. Okay, so we are not considering the signs they have taken, but I will show you how we can take the signs over here. Okay, so see, first of all, the z-axis half part is coming before the y-axis, and the remaining half part is coming at the back of the y-axis, right? And this x-axis is coming in the horizontal manner. Now think of, first of all, you see this is my x-axis, okay, and this x-axis will be positive. This y-axis, this portion of y-axis will be again positive, right? So if I have a point 1 comma 2, I will say it will lie in the first quadrant. And remember, I am talking about the front, okay, front part. So front z-axis will be always positive. Front means this portion I am talking about. See this portion, okay, this is the front part of the z-axis. Okay, this will be always positive, and the back portion means this one I am talking about. Okay, so that will be always negative, right? So if I am talking about the front one, so 1 comma 2, and then z-axis will also have the coordinate positive here because I am talking about the front. So 1 comma 2 comma 3 will be lying in the first octant. Similarly, if I have the coordinate here minus 1 comma 2, so observe minus 1 comma 2 lies in the second quadrant according to the Cartesian plane. And if I talk about the positive z-axis, means I am talking about the z-axis portion which is in the front. So suppose if I take here 3 is positive, then this will be the second octant we can see. Similarly, suppose if I take minus 1 comma minus 2, it lies in the third quadrant, and along with that if I take the positive 3, means I am talking about the positive side of the z-axis. This will be the third octant. You can see. So here in the third octant sign will be minus, minus, plus. Second octant sign will be minus, plus, plus. Similarly, the first octant sign will be plus, plus, plus. Okay. See here in the table signs as per the octant it is given. You can check. First octant plus plus plus, second octant minus plus plus. You can see the second octant sign I have written here minus plus plus. Third octant minus minus plus. Okay, look at the sign of fourth octant plus minus plus. How it is decided? See, fourth octant means the first two coordinate will lie in the, suppose if I take x is positive and y is negative, and z if I take positive. So see 1 comma minus 2 will lie in the fourth quadrant. Okay, I am talking about as per the Cartesian plane, and if I take along with that the z axis positive, then it will lie in the fourth octant. Okay, if I take the z axis positive. But now see this 4 I have taken, where everywhere I have taken the z axis positive. Suppose if I take the z-axis negative, then suppose if I take 1 comma 2 comma minus of 3, then it lies in which octant? Because now remaining 5th, 6th, 7th and 8, these 4 octants will contain z-axis negative. You can check. 5th is also containing z-axis negative, 6 also containing z-axis negative, 7 and 8 also containing the z-axis negative. Okay, whereas the first 4 octants taking the z-axis positive. Okay, so now how shall we decide that the given coordinate lie in which octant if the z-axis z coordinate is given negative. For example, suppose it is given 1 comma 2 comma minus of 3. So see, 1 comma 2 is lying in which quadrant? It is lying in the first quadrant, right? It lies in the first quadrant. I am talking about Cartesian plane. Okay, according to the Cartesian plane, 1 comma 2 lies in the first quadrant, and since my z coordinate is negative, so I will add plus 4 in this. So 1 plus 4, this will be fifth octant. Okay, in this way we can see it. One more example we'll see, or you can say that the fifth octant sign will be plus, plus, minus. You can check once. Okay, fifth octant, what is the sign given to us? Is it right? Plus, plus, minus. Similarly, suppose if I say I have one coordinate minus 2, minus 5 and minus 6. Now one thing you observe, the z coordinate is given here negative. So definitely it will be vary from 5th, 6th, 7 or 8. Okay, it will not come in the first 4 octant. So first of all you check minus 2 and minus 5 lies in which quadrant? It lies in third quadrant, right? It lies in third quadrant. So if they lie in the third quadrant, then you add 4 in that, plus 4, 4 and this 3 plus 7. So we can say that they will lie in the 7th octant. You can check the sign of the 7th octant, all will be negative. Okay, so in this manner we can find out easily the name of the octant as per the given coordinate to us. Let us start now the exercise over here. So we are going to start the first question. See the first question what they are saying over here. One more thing here I wish to add. See, suppose if we talk about the coordinate, we can easily find out the where they are lying in which octant over there. That method I have told you. Moreover, we can clarify as the questions we will do it. Okay. But see, suppose if we talk about the Cartesian plane, suppose if I take you at Cartesian plane, so see, I can say easily 1 comma 2 lies in the first quadrant. Okay, but suppose if I ask you 0 comma 2 lie in which quadrant? So 0 comma 2 will never lie in any of the quadrant. It will lie onto the axis. Same thing will be applicable here also. Suppose if I say here, suppose one coordinate is missing. Okay, one coordinate. We are talking about one coordinate is given 0. So 3, 0, 5. It is given like that. So in that case, this coordinate will lie on XOZ plane because see here y coordinate is 0. So it will lie on XOZ plane. In that case, the X and Z plane will form the value 3 and 5 respectively, and they will lie particularly in that plane. Similarly, suppose if it is given 0 comma 5 comma 7, so this particular coordinate will lie in y o z plane. That you need to remember. Okay, so let us start the first question. See, exercise 10.1, I'm sorry, 12.1 it is. So exercise 12.1 I am taking here. See the first question, what is given to us? A point is on the x-axis. What are its y coordinate and z coordinate? Now think of if a point lie onto the only x-axis. So other coordinates will be definitely 0. We know from the coordinate plane also. Suppose think of in the coordinate plane, if a point lie onto the x-axis, definitely its y coordinate will be 0. And here in the three-dimensional plane, the z coordinate will be also 0. So here we'll say y comma z coordinate will be 0. Okay, so this is your first answer. Simple. This in this chapter, see, there is very few things we can teach to you. Okay, only we can give you the introduction. The remaining part will come to the class 12. Class 12, three-dimensional geometry. You will learn about the line separately. Separate chapter is there, line, and separate chapter is there for plane. So there is a many more things are there in the class 12 to teach you. But in class 11, there are very few things we can discuss over here as per the limitation of the syllabus. A point is in the xz plane. Xz means you can assume it is XOZ plane. O means here origin we are talking about. Okay. So what can you say about its y coordinate? I have explained you, if a point have the coordinate 3, 0, 5, then it will lie definitely in XOZ plane, means its y coordinate is already 0. So here we can say that the y coordinate will be 0. Okay, this is your second question answer. Y coordinate is 0. Now see what they are saying. Name the octant in which the following points lie. First of all, look at the first one, 1, 2, 3. Right? Now see what method I have told you. You think of, suppose if I draw here one coordinate plane. Okay, this is x-axis and this is y-axis. You need to think of the positive side of the z-axis is in your front and the negative side of the z-axis will be at the back side. Okay, that way we will find out. Now see, first of all think of 1, 2 lies in which quadrant? 1, 2 lies in first quadrant. Okay, and if the z-axis is given positive, you need not to add anything, or you can say you have to add 0. Okay, so here we can say that 1, 2, 3 will lie in first octant. This is your first answer. Okay, similarly look at the second one, 4, minus 2, 3. First of all think of 4, minus 2 lies in which quadrant? 4 means positive, x is positive and y is negative. So x is positive and y is negative, that will be coming in the fourth quadrant. See here x is positive and y is negative, right? So we can say that it lies in the fourth quadrant. And since again the z coordinate is positive, so we need not do anything. We can say the coordinate 4, minus 2, 3 will lie in the fourth octant only. Okay, similarly, let us see some more points over here to clarify. 4, minus 2, minus 5. Same point is given, only they have made the z coordinate is negative. Once again think 4, minus 2 lies in the fourth quadrant only. Okay, this is same. Now since our z coordinate is negative, so we will add here 4. Okay, so 4 plus 4, this will be 8. So we can say 4, minus 2, minus 5 will lie in the 8 octant. Right? Let us see one or two more. Then it is given to us minus 4, 2, minus 5. Minus 4, 2, 1 minute. Minus 4, 2, minus 5. Yes. Okay. First of all, think of minus 4, 2. Lie in which quadrant? X is negative. Okay. And Y is positive. So that will lie in the second quadrant. So second quadrant. Okay, and since the z coordinate is negative, we shall add 4 in this. So 4 plus 2, this will be 6. So we can say minus 4, 2 and then minus 5 will lie in the sixth octant. Okay, one more, last we can see it. Suppose if I take the last one, minus 2, minus 4, minus 7. Okay, so minus 2, minus 4, and then minus 7. Think of minus 2 and minus 4 lie in which quadrant? They will lie in the third quadrant, because in the third quadrant these 2 points will be negative. Okay, remember we are taking first 2 points only, because it is very difficult to take all the 3 points and think about the octant. So it is better take first 2 points in the Cartesian plane, and think of minus 2 comma minus 4 lies in which quadrant. So they will lie in the third quadrant, because in the third quadrant both are negative. Right, now since here the z coordinate is given negative, so add 4 in that. Okay, so if you add 4 plus 3 7, so we can say minus 2 minus 4 and minus 7 will lie in the 7th octant. Okay, here remember, here name will come as a octant. Okay, initially we are taking the help of the quadrant and we are reaching to the name of the octant. Now I think it is clear to you. You can find out easily the remaining points. Now we shall discuss at the last, fill in the blanks. The x-axis and the y-axis taken together determine a plane known as, see, we are taking only the x-axis and the y-axis. Okay, but remember we are not writing here Cartesian plane. Normally we can say x and y-axis only you are taking, that will be a Cartesian plane. But since we are having the context of three-dimensional geometry, so we will say this plane will be called as XOY plane, because z-axis we shall mark as absent. Okay, so only x and y, but they are passing from the origin, that's why it is taken as XOY plane. The coordinate of a point in the xy plane, xy means they are talking about XOY only, are of the form. So see here x and y are given, but again z is not there. So the coordinate will be in the form x is non-negative, y is non-negative, and z is 0. Okay, sorry, x is non-zero, y is non-zero, and z is 0 over here. So we can say they will be into this form. And the last one is coordinate plane divide the space into how many octants? It divides into 8 octants that we have seen over here. Okay, so I hope this fundamental is clear to you. Moreover, we shall do it in the exercise 12.2. Okay, thank you.